In this video we're going to look at our derivative rules again and talk about tangent lines. So let's start by finding the derivative of each of these. This first one is pretty easy. The derivative, of course, is just going to require a power rule. So derivative of 5x to the fourth would be 20x cubed. Derivative of 7x squared would just be 14x. Next, we got to do the derivative of 5x multiplied by sine x. Well, let me just remind you here we have a product. So we've got two terms, 5x and sine x. Okay. So in the product rule, remember we always do first multiplied by derivative of the second. Derivative of sine is cosine. Plus the second multiplied by derivative of the first, which is 5. And usually we like to have our the numbers go first and the trig stuff go second, so I'm going to just write this as 5x cosine x plus 5 sine x. Right? So the product rule, just remember it's always the first times the derivative of the second plus the second times derivative of the first. First d last plus last d first. Alright. This last one we're going to need quotient rule. So please remember quotient rule always goes low, d high, derivative of the high is just 7, minus high, d low, cross the line and square the low. Okay, now we could be done there. Let me just clean this up a little bit. Okay, let me just look at the top. 7x times 7, 42x plus 7. If I multiply that through, and then minus, so minus 42x plus 30. So the 42x's are gone. So this whole thing just reduces to be 37 over 6x plus 1 squared, like that. Now let's go back and look at the tangent lines. And of course, a tangent line you need both a point and a slope. So I know the point, at least the x-coordinates here. The x is 2. To get the y, I just plug 2 back in. So 5 times 16 is 80, minus 7 times 4, so 80 minus 28 is 52. So that's my y coordinate. Now my slope, when I plug the derivative in, or plug 2 into the derivative, I get 20 multiplied by 8, so 160 minus 28 is 132. So my tangent line is going to be y equals 132 x minus 2 plus 52. Okay, so just remember, I get the slope by plugging 2 into the derivative. Okay, you could just say it's f prime 2. It's 132. Alright, well let's go down here. I know x is pi. To get the y coordinate, I plug pi in here, so 5 times pi times the sine of pi, which is 0. Well, 5 pi times 0 is 0. To get the slope, I would do f prime of pi, so just plug pi in here. Well, let's see, 5 pi times the cosine of pi. Cosine of pi is negative 1. So negative 5 pi plus 0 is negative 5 pi. So kind of a weird looking slope. That is the slope. So we're going to have y equals negative 5 pi times x minus pi plus 0. Okay, so that's our tangent line. All right, in the last example, if I plug 0 in, 7 times 0 minus 5 over 0 plus 1. So the point here is 0, negative 5. And I plug 0 in to my derivative. 37 over 1 squared is just 37. So my tangent line is going to be y equals 37 times x minus 0 minus 5. So that's my tangent line for that one. Finally, I just wanted to talk about and give some advice on avoiding some of the harder rules. You know, quotient rule, product rule are wonderful, and of course you can use them. But maybe we have some other methods so we don't have to spend time doing the harder rules. Maybe we can get back to the easier ones. So I wanted to talk about, there are kind of two ways to approach this. Both will lead you to the same thing. But let's say, what if I rewrote this as x cubed over x squared minus the square root of x over x squared. Well, x cubed divided by x squared is just x. Okay. The square root of x, what if I, instead of having square root of x, what if I rewrote that as x to the 1/2? So x to the 1/2 divided by x squared, well, 1/2 minus 2 is negative 1/2. So this would become x to the negative 3/2. And now, look how easy it would be to just use power rule. Okay. Derivative of x is 1, minus, we bring the negative out front, so minus 3/2, x to the negative 5/2, which we could rewrite as 1 plus 3 over 2x to the 5/2, like that. Okay. Even better, we could rewrite that bottom with a root. So it'd be the square root of x to the 5th. Even nicer maybe that way. The other way we could approach this would be to turn it into a multiplication. So we have x cubed minus the square root of x multiplied by x to the negative 2nd. Okay, just taking that x squared in the denominator and moving it up. And again, I don't want to use product rule here. I certainly could, but why don't I just multiply it out? X cubed multiplied by x to the negative 2nd is just x. And again, ignoring that, making it x to the 1/2. X to the 1/2 times x to the negative 2nd is x to the negative 3/2. And now, of course, I'm at the same exact spot. I just continue the same way. But we can maybe manipulate these with some algebra at the beginning to avoid having to do some of the harder derivative rules. Certainly, quotient rule will work here. It will just take you longer to simplify it down to your final answer.